Hello everybody. Hello my dear students. I hope you are fine. Today we will start the revision on science in second term. In second term we studied two units. Unit 1, levers. In this unit we studied types of levers and law of levers. Unit 2, electricity. In this unit we studied electric lamps and dangers of electricity. Before the revision, I will remember some information with you in the unit. The lever. What is the meaning of the lever? The lever is a rigid bar, straight or curved, that rotates around fixed point. This fixed point called fulcrum. And the lever is affected by two forces, effort force and resistance force. Any lever consists of three components. Number 1, resistance force, which results from the weight of body that we want to move and has symbol R. 2, an effort force that is exerted by a person to equilibrate the resistance and has symbol F. 3, fulcrum. This is fixed point where the bar rotates on and has symbol O. In our daily life, we use many examples of levers, like bottle opener, nutcracker, wheelbarrow, crowbar, manual broom, tweezers, stapler, scissors, ice holder, and suction pump. The levers have many importance in our daily life. Number 1, increasing force. Number 2, increasing distance, like manual broom. 3, increasing speed as hockey bat. 4, moving the force from one place to another, like manual broom. 5, accuracy in performance, like tweezers. 6, avoid dangers, like coal holder. Classes of levers. We studied types of levers, and we have three types. Number 1, first class lever. Number 2, second class lever. Number 3, third class lever. What's the meaning of first class lever? First class lever is the lever which has the fulcrum, is the midpoint between effort force and resistance force. Second class lever is the lever which has resistance force is the midpoint between fulcrum and effort force. 3. Third class lever is the lever which has the effort force is midpoint between fulcrum and resistance force. Lesson 2, Law of Lever and the Conservation of Effort. In this lesson we studied the law of levers, which is R times its arm equal F times its arm. R, it is a symbol of resistance force. F, it is a symbol of effort force. In first class levers, we find three possibilities in this type. A, if the arm of the effort force shorter than the arm of resistance force, we find the effort force is larger than the resistance force, so in this possibility, the lever doesn't save effort or has no mechanical benefit. In case B, the arm of effort force is equal to the arm of resistance, we find the effort force is equal resistance force, and in this possibility also, the lever doesn't save effort or has no mechanical benefits. C. If the effort force arm longer than resistance arm, as in crowbar or nutcracker, we find the effort force is smaller than the resistance force, and in this possibility, save effort and has mechanical benefits. Second class levers. In second class lever, we find the resistance force is larger than effort force, and second class levers always conserve effort and have mechanical benefits. 3. Third class levers. These types of lever always don't have mechanical benefit and don't conserve effort because effort force is larger than resistance force. Now we'll start the revision. Question number 1. Complete the following statements. Number 1. Space is a rigid bar that rotates around space and is affected by space and an effort force. The answer is lever is a rigid bar that rotates around fulcrum and is affected by resistance force and an effort force. This is definition of lever. 2. Space, and space are from the importance of levers. We talk the importance of levers like increasing force, increasing speed, and increasing distance. 3. Space is a lever that used to avoid dangers, while space is a lever that used to increasing force. We find third-class lever like coal holder is a lever that used to avoid danger, while second-class lever like nutcracker is a lever that used to increasing force. Question number 4. Stapler and wheelbarrow have the space between fulcrum and space. Stapler and wheelbarrow have the resistance force between fulcrum and effort force because they are from the second-class lever. 5. Suction pump is while space is second-class lever. The answer is suction pump is first-class lever while nutcracker is second-class lever. 6. Levers rotates around fixed point called fulcrum. Question number 7. The arm of force is the distance between space and space. The arm of force is the distance between effort force and fulcrum. 8. When the force arm equals 5 meter and the resistance arm equal 1 meter, so space is larger than space. In this question, we find the force arm is longer than resistance arm, so the resistance force is larger than effort force. 9. The resistance arm is measured by centimeter or meter units. 10. The lever conserves effort when space arm is longer than space arm. The levers which conserve effort is second-class lever, so the lever conserves effort when effort force arm is longer than resistance arm. 11. The only type of levers where the arm of force and the arm of resistance are equal is the first-class lever. 12. The first-class lever have mechanical benefit when space is longer than space. The first-class lever have mechanical benefit when effort force arm is longer than resistance arm. Question number 2. Give reasons for each of the following. Number 1. Sometimes the first-class levers save efforts because it is used to save the exerted effort by using small force to move heavy loads. 2. Balance is a first-class lever, while fishing tool is a third-class lever because in balance the fulcrum between effort force and resistance force, while fishing tool has effort force between fulcrum and resistance force. 3. The levers have many importance because it has many important as increase force, increasing speed, increasing distance, moving force from one place to another, and avoid danger. 4. Doctors and watchmakers use tweezers as lever because or to pick up very small objects. 5. Sometimes the first class levers save effort because in the first class lever, when the arm of force is longer than the arm of resistance, in this case they save effort. But when the arm of force is smaller than the arm of resistance, in this case they don't save effort. 6. Nutcracker and wheelbarrow have mechanical benefits because they are from second class levers, and in this case we find that the arm of force is always longer than the arm of resistance and effort force is smaller than resistance force. 7. The third class levers always don't conserve effort because in this case the arm of force is always shorter than the arm of resistance. Question number 8. Some of levers are important to men although they don't save effort because in this case the arm of force is always longer than the arm of resistance and effort force is smaller than resistance force. Question number 3. Write a scientific term. Number 1. A force that results from the body we want to move it. This force is called effort force. 2. Coal holder, tweezers, fishing tools. They are from third class lever. They are example of third class lever. 3. The type of levers that is its midpoint is the effort force. In this type is third class lever. 4. A simple machine that increase force, speed, and distance is this definition of lever. 5. The fixed point at which the lever rotates is fulcrum. 6. The force which results from the weight of an object we want to move, this definition of resistance force. 7. The distance between effort force and fulcrum, this distance is effort force arm. 8. A type of levers where the effort force is sometimes smaller than the resistance force. In this type, we find the lever conserve effort, so it is a second class levers means. 9. A type of levers that always conserve effort or has mechanical benefits. This type is second class levers. 10. A type of levers that sometimes its force arm equals the resistance arm is first class lever. Question number 4. Problems. Problem 1. The exerted force of the first class lever equals 500 Newton and the length of its arm is 20 centimeters. So the effort force arm is equal 20 centimeters and is affected by resistance with a value of 200 Newton. Find the length of the arm of the resistance. Solution. According to the law of lever, effort force time its arm equal resistance force time its arm, we solve the problem. So the resistance arm equal 500 times 20 divide 200, it is equal 50 centimeters. Problem 2. The affecting force on second class lever equals 200 Newton and the length of its arm is 50 centimeters. So the effort force arm is equal 50 centimeters. If the value of the resistance is 1000 Newton, calculate the value of resistance arm. Solution. According to the law of lever, F times its arm equal R times its arm, we find the length of resistance arm. So 200 times 50 divide 1000. The resistance arm is equal 10 centimeter. Thank you. Goodbye.